Hello bachcho, how are you? I hope you all are doing good. Okay, without any delay, let's start our new session. And here comes your Vignesh from Mr. Vignesh Tutorials, and I am going to teach you your M1 Max Engineering today matrices chapter. I am going to teach you a new concept. Uh, did I explain you about inverse of matrix and two methods, right? I explained you in the last class. Today we are going to study about the new concept, that is our Gauss Jordan method. Okay, we are going to see what is Gauss Jordan method. It is also one of the type of your normal form or finding rank of matrix in that type of form, where to get the equations, just like your eigen vectors, how you are finding the solutions of that linear equations we are going to see. So without any delay, let's start our session. Gauss Jordan method. What is Gauss Jordan method is finding solutions of linear equations, that is x1, x2, x3, whatever you can tell. We can find this by converting matrix A into simplest form. That means our matrix should be of this form. Your A11, A12, A13, A21, A22, A22, A23, A33. Our matrix should be converted into this form, into x1, x2, x3 is equal to 0. So then you will get three equations, equation 1, equation 2, equation 3. So here you will be getting directly our A33 value, x3 value. From here, if you substitute this x3 value in this, you will be getting x2 value. And these two values, if you substitute here, you will get x1 value. So it's very easy, students. Please just concentrate here. Just finding the values of that linear equations variables by most simplest form conversion of the matrix A. This method is called Gauss Jordan method. How we are doing this? Like we have A11, A12, so on, like A33 elements in the matrix of 3 by 3 matrix. So that one we are converting by row and column operations and making into this one, like an upper triangle matrix we are making. And when we are multiplying with this vector form, it is equal to 0, like characteristic equation. So we get x3 value from third equation, x2 from second, and x1 from first equation by substituting 2 and 3 in 1. Okay, I hope you got it. Please note it down, this one. Now I am going to solve for an example. The example is x minus y plus 2z is equal to 2. X minus yz, y plus 2z is equal to 2. Sorry. Two x plus y plus 4z is equal to 7. 2x plus y plus 4z is equal to 7. 4x minus y plus z equal to 4. 4x plus y minus y plus z equal to 4. This is our question. Okay. Generally in our matrix we have only 3 columns, right? But in our augmented matrix we have 4 columns. 3 rows and 4 columns. What is that fourth column? This is our fourth column. Fourth column in augmented matrix. Augmented matrix. We say these elements are our matrix A, this is for matrix B. So our augmented matrix representation, this is our augmented matrix. AM I am denoting it as with abbreviation. Augmented matrix is 1, coefficients I am writing 1, minus 1, 2, 2, 1, 4, 4 minus 1, 1, sorry, with extra column 2, 7, 4. This is a 3 into 4 augmented matrix. Okay, I hope you understood till here. Now I will do some operations. R2 implies R2 minus 2R1, R3 implies R3 minus 4R1. I'll rub this side 1. Okay. Now see here. This matrix R2 implies R2 minus 2R1, R3 implies R3 minus 4R1. Yes? Okay. After substituting this, what I'll get? Why I'm doing this operation only means to get zeros this position and this position. My R1 is not changed. So I wrote our R1 as it is, it's unchanged. R2 becomes, this becomes 0. 1 minus of minus 2. So 1 plus 2 is 3. 4 minus 4 is 0. 7 minus 4 is 3. Okay, we got this one. Our R3 becomes this one 0. Minus 1, minus 4, minus 5. Minus 1 plus 4, right? So it becomes plus 3. And 1 minus 8 is minus 7. And 4 minus 8 is minus 4. We got this one. Yes? Okay. Now what? Now let's do R2 and R3. Let's interchange it. Okay? We'll be getting 1 minus 1, 2, 2. 0, 3 minus 7 minus 4. 0, 3, 0, 3. Why like this means to make more zeros in the bottommost column or bottommost row. Okay? Now R3 implies R3 minus R2 I'll do R3 implies R3 minus R2. I'll subtract. So I'll get 1 minus 1, 2, 2. 0, 3 minus 7 minus 4. Here I'll get 0, 0. Here I'll get 7. Here I'll get 7. Yes? Now this is the matrix. In this, if this matrix is equals to, it's the number of unknowns, then I can write like, for this matrix I can write the equations. I'll have this part and I'll tell you. For this matrix we can write it as your x into coefficient is 1 minus y into coefficient is y. For the first row I am telling, plus z into 2 is 2z is equals to 2. The leftover part is on the RHS, let's say. And for second equation would be, this is our first equation. Second equation is 3y minus 7z is equal to minus 4. Let this be equation 2. Our third equation would be 7z is equal to 7. From here z equal to 1, let it by equation 3. We got z value. Substitute 3 into, so 2 implies we get 3y minus 7 into 1 is equal to minus 4. So 3y is equal to 7 minus 4 is 3. So y is equal to 1. We got this one. Now substitute 2 and 3 in 1. 1 implies you get x minus y value is 1 plus 2 times z value is 1 is equal to 2. 2 to get cancelled. X is equal to 1. So you got all values. X comma y comma z is equal to 1 comma 1 comma 1. You got all values of this linear homogeneous solutions, and the values are 1 comma 1 comma 1. So x value is 1, y value is 1, z value is 1, which satisfy our given question. We have rubbed our question. It was in the previous before rubbing this, it was there. So in those values this will be substituted and it will be exactly fitted. So it's our solution. So finding solution in this method is called Gauss Jordan method. Again I am telling how to do this one method is, we have to find the augmented matrix. Like given linear equations, we have to write in the format of a matrix A which has coefficients of x, y, z in the respective rows and columns and separated by a line. The other side, the RHS value should be written there. That is our B matrix, let's say. So A by B, we denote it as A by B, is called as augmented matrix. And that matrix we are solving simplified form to get a triangular, lower triangular or upper triangular matrix in this form, so that we will get an easy solutions here and finding the solutions of the linear equations. I hope it's very clear, a very pretty beautiful problem with a very good explanation, I hope. So I hope you all enjoyed it. If you have any kind of queries, please mention in the comment section. Okay, and note it down very carefully, solve very carefully, take a screenshot of it. Okay, so this is what about all our session today, guys. So I hope you all enjoyed it, and please like, share, comment my videos and subscribe my channel, and for further more updates please press on the bell icon. So finally I conclude with like, share, subscribe my channel, comment it and press bell icon for further more updates. This is your Vignesh from Vignesh Tutorials signing off.